All right, my friends, let's go through this today. This is not hard stuff, but I want everyone to look me straight up here. I've been teaching calculus for a while, right? Students go from Algebra 1 to Geometry to Algebra 2 to Pre-Calculus. Pre-Calculus takes all the previous math classes and put it together. These are some of the worst errors I see my students make. So today, I want you to be totally engaged and make sure that you don't do it. Because I'm going to tell you, don't do, and make note of that. Because if you do what I say don't do, you're not going to get these right. And students don't focus on it, and then like on a standardized test or like on the pre-cal where I'm just talking, I'm like, let's go, they will do stuff wrong. And these are errors that are made very often. Now, when we talk about rational expressions, okay, please just know that means it's just algebraic things written as a what? Fraction. So rational expressions mean fractions. Rational numbers were numbers that could be written as fractions that either had repeating decimals or not, or terminating decimals, correct? So notice we're using terminology that are very similar to each other. Now, I want you to look at this simple improper fraction. 24 over 9. Would I let you give that to me as an answer? Why? Yeah, because it's not completely simplified. How do you know that it can simplify? Can what? Oh, you said 3 can divide out of both of them. Which really does that mean 3 is a factor of both of them? All right, so I'm writing stuff down that we naturally don't do because we work with fractions a lot. But you guys agree with me? It's really going to, and of course I didn't move this. You guys know I'm going to cause issues if it's going to go bad somewhere in this. Okay, that we got 8 times 3 over 3 times 3. Would you guys agree? So I could rewrite my numbers into their factored form, or into at least 2 factors. And we're like, okay, what do we know? 3 divided by 3 is what number? 1. So really we're going 8/3 times 1 equals 8/3. And do we leave stuff as improper fractions? And the answer is what? Yes. Why take the time to make it a mixed number unless they ask you to? So the fact is, we know that we can simplify if they have a common factor. So when will it simplify? When you have common what? Common factors. The factors don't happen unless you're multiplying. Just remember that. Factors don't happen unless you're what? Multiplying. Okay. So let's think about that right now. Looking at the following. First fraction. The quantity x plus 4 times the quantity x plus 1. All over the quantity x plus 4 times the quantity x minus 3. Can that fraction simplify? What comes out? The x plus 4, because they're common factors. So really, in anything divided by itself is what lovely number? 1. Now, what do we normally do? Do you guys remember the good old days? Right? So, but you should be at the spot where, shouldn't we almost do it like that instead? Because anything divided by itself is what number? 1. So the fact is, if I was to simplify this, this would be the what? X plus 1 over x minus 3. Now, can anyone guess what my students would probably do in pre-calculus and get in trouble for? You should stop. This is actually the simplest form. But this is what happens to my students at higher level. This is also like, this happens a lot in Algebra 1 when you first learn this. What do people do wrong? They try to divide the x's. Can you divide the x's? No. Because those are terms, not what? Factors. Factors are with multiplying. Terms are with addition and subtraction. Are you with me on this? So here's the thing. Don't divide terms. Are you guys with me on that? Only divide factors. All right, how about the next one? 3x plus 1 divided by 3x minus 4. Can we simplify this? can't simplify this because those are terms, not what? Not factors. Now, I keep saying the words factors, which means we're going to have to do what probably to get them? Factor. Right? How about the next one? 3 times the quantity x plus 4 times over 3 times the quantity x minus 1. The 3's, because all of a sudden, these are what? They're factors. Because we're multiplying, correct? So those will simplify out to be what? Lovely number 1. So what do we get left? You already see, well, you don't have that parentheses there, but are we good? So this one's one of those, yes. Okay, how about the next one? Yeah, again, these are terms. So can we work with this? So the answer for that one is going to be a resounding what? No. Those are terms. These are terms, correct? Not what? Not factors. Now, please understand. Put fireworks, put something, highlight this, do something that helps you go here, and make sure you never, ever do. Never, ever cancel terms. What are terms again? What are they separated by what?
Addition and subtraction.
Yep, by addition or subtraction signs. Very good. All right? Those are terms. Only cancel out what? Only cancel out factors. And this is, remember, they're separated by what? A lot of times it's parentheses, right? They're separated by multiplication. Know the difference. Okay? So, we're going to warm up. This is pretty simple. You just have to be able to simplify fractions. Now, the first one, should we know how to simplify this already?
Yes.
How would we simplify this before in our previous lessons this semester? What would we do? Yeah, we would divide the number. Really, what are we taking out of both? The top and the bottom. We're factoring out a what? 3. Okay. So we're like, that's 1. This would leave what? 4. And then didn't we use our exponent rule to simplify these? Okay. So that doesn't change. So I look at the x squared and x to the first. How do we do that? Subtract, because it's a fraction, right? We're doing division. You take the largest one, subtract the smaller one, and keep it where the larger one is. So what happens? Top. What has to stay on the bottom here? The 4. Now we have a y and a y squared. Yep. Now, here's the fraction method of doing this. It's miserable. The fraction method of this is really the following. 3 times x times y over 3 times, and I'd go 4 here, but you can go 2 if you wanted to, times x times y times y. All right, are you seeing where this is? That gives you a 1. This one gives you a 1. And what? Did we get the same thing? Do you see why, like, if you know your exponential rules, you save time? If you know how to simplify fractions, you save time? Yes. All right, now let's look at the next one. Now, it says write the following in lowest terms, which means the following. No common what? Factors. So how do I get common factors? You factor. I know, profound moment here. To get common factors, you gotta what? Factor. So look at this first one. Can I factor the numerator? What do you look for first?
Great.
So what is it? So the quantity, guys, I think I might cry. You just did factory by grouping where you had to do this and you aced it. And now I'm asking you for a simple binomial with a GCF and we're not getting it right. Oh, I'm having issues. Okay, now let's look at the bottom one. Completely factor. Can we factor the bottom?
Yes.
Yes.
People, is this a difference of squares? All right, so we have k plus 2 times k minus 2. Do we have any common factor now? So what does this simplify down to? 3 over k plus 2. That was said with too much sarcasm. Come on, this was simple.
Come on, man.
Guys, here's the hint. You must completely factor both the numerator and the denominator. Okay? Because you can only simplify out awesomeness factors. Are you guys good with it? Let's try the next one. Oh, wait. Do you see why now that I'm telling you, we got to make sure that we knew how to factor before we did this? With this first one, let's look at it and do just numerator first, denominator first. You just do them separately. So basically, it's like a double factoring problem. So we got 2p squared plus 7p minus 4. Is there a greatest common factor? Okay. So then we count terms. How many? Trial and error. It's subtraction at the end. So what? All right. Awesome. Guys, first one, 2p squared. What do we got? 2p and b. Okay. Factors of 4. All right. A lot of people say 2 and 2. Think about it. Can you use that one? I can't use 2 and 2 because no matter what, do I get a greatest common factor here? So what's my only option? So notice I can't even put the 4 with the 2. Now, did I do this correctly? Why did someone scream no at me? Because I agree with you. Because that's negative 8p. Yep, that's a positive 1p. That adds to be a negative 7p. And what did I have over here? All right, so I just have to switch signs. So the cool thing is the rules don't change with factoring. Okay, so we got the numerator done. Now let's go ahead and factor the denominator. Always go through the very first process again. Can we take out greatest common factor? Yeah. So we have 5p times the quantity what? Now, can we actually take out a common factor? Yeah, which is going to be what? Yeah, that basically comes to the number 1, correct? So what is our final answer? Now, am I going to simplify more? Guys, can I simplify more? No, because this is terms, not what? Factors. So we cannot go further. Okay. Now, we're going to multiply and divide and subtract doing this now. Aren't you so excited? All right, guys, we should remember how to multiply fractions. Now, here's the cool part about this. You can do it the hard way. The hard way would be going like you just multiply across. Do not write down. Did everyone hear me on this? Do not write down. You could do multiply across, and then what do you have to do? Simplify. And if we simplify, do you guys agree with me? I could take 2 out of both and be 6/5.
Yeah.
Right? Okay. What if I don't want to multiply so many numbers? When you are multiplying fractions, can we take out common factors early? So, but remember it has to be numerator denominator when you're doing this. Like 3 and 5 we know they don't simplify, but can 2 divide into 4? So we know that becomes 2. Then we multiply across, correct? So that becomes 6 over what? Now, most logical people who are pretty confident in their multiplication process and stuff like that would do this method. Would you agree? Much better than the one I just showed? Yeah, we have to do that. But to do that, don't you need to know your factors? So in order to do this, you're still just going to factor completely. Are you guys with me on that? So let's look at this first one here. Can we do any simplifying before we go with this one? All right, what can come out? Yep. And notice I do put the numbers there, friends. Why? Because I don't want to forget them. I need to make sure when I multiply them, once I've taken out this common factor stuff, that I still multiply straight across. Okay, anything else? 5a. All right, so 5a can go into 15a squared how many times? All right, now Now you multiply across. 3a times 1 is? 2 times 1 is? 2. Would you guys agree? Guys, I know someone's like, that feels like I've done this before. Yes, because you have. This is Algebra 1. Okay? So we're reviewing key Algebra 1 concepts. Now let's go. You are. Now we're doing Algebra 2. All right. Now, I can't simplify any of this because there's no common factors. So when you're doing this, my friends, you need to factor each one of the parts. So when we're working with this, I know this is kind of a pain. So look at the first equation. Can I factor anything out of 5x minus 15?
Yes.
So I get 5 times the quantity, x minus 3. Okay, denominator. Can I pull anything out of there? Yeah. So we go 3 times the quantity, x plus 3. Okay, we just got the first fraction done. Time for second fraction. Can I take anything out of 4x plus 12? I can factor out greatest common factor. So that'd be x plus 3. Okay, let's look at our last one here. Can I take anything out of 6x minus 18? Which one? Greatest common? Greatest common factor. Okay. I love how they yell at you for you. Like they're like, we're gonna yell at her. Okay. Okay. X minus 3. I'm the only one who gets to yell. Just remember that. Okay. With this one, can we simplify any of these now? Yeah, the x minus 3 goes here and here. Would you guys agree? What's our other one? X plus 3's, those are gone. Is there anything else? No, there's nothing else, right? I can't simplify the 3 and 6 because they're both where? Denominator, right? Only way you can simplify that when you're multiplying is if one's numerator and one's denominator. Okay, so great. So now you just multiply across. 5 times 1 times 4 times 1. What is it?
20 over 8.
Oh, are we done?
No.
Because you have to ask yourself, like factoring, am I in simplest form? What can come out of both? So we had to take, that would be 10, and this would be what? So it's 10. Oh, so scholarly people, should we have noticed something earlier? Should we have noticed that we could have simplified further? The 4 and the 6 both had common what? Factors. So here's the thing. It's wrong if it's not in simplest form. It's wrong. Okay, let's go to another one. Okay, yes.
If we forget to simplify before multiplying,
You can still simplify at the end. You just have to factor everything at the end. So always make sure, like that one there, we looked at it like, oh wait, I should have taken the 2 out. As long as you got it there, you're good. Again, be mathematically what? Correct. Okay, guys, quick review here. To divide fractions, what do? So I'm really going 4/5 times what?
oh yeah.
3/2. Now can we simplify? Yeah, because now we can go common factors, and we know that would be 2. And then do we just multiply across again? All right, so 2 times 3 is what? 2 times 3 is what? 6. And then 5 times 1 is? I'm such the non-kind math teacher. I laugh when you guys multiply and divide and add and subtract wrong. I'm so loving. Okay. Sorry. All right. Someday I'll look kinder. Okay. Guys, here's the key thing. You still need to factor completely when you're doing this. Okay? So, when you're doing this first one here, the first one, does it flip at all? No. So when you rewrite it, you just go t minus 2 over 8. But make sure you do what with your other fraction? Flip it. So I get 6 over t minus 2. Now talk to me. Is there any simplifying I can do?
A lot.
Yeah, the cool thing, do we have a common factor of t minus 2? Anything else? 2 can come out of 8 and also out of what? Now multiply across. Once you've taken out all common factors, it's just going to be what value? Okay. Now, it's so easy. Don't change. Here's the key. Factor completely, and you're going to be fine. I think for most of you, the first thing you should do is to flip first. And here's what I mean by this, okay? Now, this is different for other teachers, but I would do this first. But here's the problem. If you rewrite something wrong, does it mess up the whole problem? Guess what you guys like to do once in a while? Mess up the whole problem. But be careful. Once we do this, what do I have to do to every numerator and denominator now for each one of these? Factor it. So think we can do it? All right. So let's do the first fraction. So I have 2k squared minus k minus 1. Is there a GCF? No. How many terms? So we're going to go into our binomials. What are the signs inside? Addition and, yep, plus and minus. Okay, factors of 2k squared. 2k and k. All right, I love this one. Factors of 1. All right, did we put the negative in the right spot? How do we know? Test it. Negative 2k plus a positive 1k gives us a negative what? Negative k. Are we good? So we did it right this time. It was nice. Right? Do the what? Gotta check oi. Then we go, can I go further? Can I go any further with this? No. Okay. Denominator, is there a greatest common factor? No. Okay. So then we're going to go, all right, trinomials. So we're going to try. Trial and error. So what are our signs on the inside? Yep, both addition. So what goes factors of 2k squared? 2k and k. And then factors of 3. 3 and 1. I'm going to put a 1 and 3 here. Did I put it in the right spot? Why did you know I didn't do it in the right spot? Yeah, because we got 6 plus 1, that gives us what? 7. So what do we have to do with our 1 and our 3 if it's going to let me do it today? I don't know why it doesn't like me to erase sometimes. Here we go. We'll just make it easier when it's having those days. Okay, so when we do, we got to switch it. Now are we okay? Now notice, I'm not simplifying yet. I just left it alone. Because I'm going to go ahead now and simplify my next one. Guys, we have 2k squared plus k minus 3. Is there a greatest common factor? So it's 3 terms. So we're going to go into our binomials. Factors, and what are our signs, by the way? So sorry, I forgot the signs. Plus or minus. What do we have? 2k and what? K. Factors of 3. 3 and 1. Am I going to go where I put them? Yep, we're going to have to flip the 2 numbers. That's right. Because we have a negative, love how I just quit erasing. A negative 6 plus a positive 1 gives us a negative 5. Is that what I wanted? No. So instead, we need to go like this. Now does it work? A positive 3k minus 2k. Does that give us a positive 1k?
Yes.
Okay. Are we good? Can we go further on the top? No. Right? Because there's no difference of squares or sum or difference of cubes. I don't know, that could show up. All right, bottom one. 4k squared minus 1. GCF? No GCF? But it's a sum. I mean, it's not sum. It's a difference. Boy, I can really speak today. Woo! Difference of squares. What are my 2 values? Plus and minus. 2k plus 1 and what? Yep. 2k minus 1. Okay, now can we start simplifying our common factors? All right, do you guys see that a 2k plus 1 is here? You guys agree? Okay, what do we get for our next one here? We have our 2k plus 3. Anything else? No? All right, is there anything else we can do? No. So how would we write this one if that's the case? You could write it 2 different ways. You can go k minus 1 times k minus 1 over the quantity k plus 1 times the quantity 2k minus 1. Now, notice, did I ask you to simplify this? Now, if I was a really amazing math teacher, I would say, all to do. I don't want you to do it. This is called simplest factored form. Why would I prefer this method besides the fact that we should all know how to simplify by now? This lets me know you took out all the common what? Factors. So this is called simplest factored form. Now, someone goes, well, how do I know to use that? Look at me. I want simplest factored form. You know how to simplify. I'm not testing that. I'm like, can you reduce? Are you guys with me on that? Yes, sir.
Are we able to leave K minus 1
You could also write it like this.
K minus 1 squared? Okay.
Would that also be simplest factor?
Yep. Either one of those works for me. Fair? Because when we factored earlier and we had the same thing, did we square it as well? So either one of those are good. Okay. Now, here's the thing. You're supposed to know the processes of all of these. Now, I'm going to do, I don't know. Should we just do the first one? I think we have time for it. The other one is on your filled in notes. But the key with this is, the key is factor what? Factor completely. And what I mean by that, numerators and denominators. So first things first, I would go r squared plus r minus 6 over r squared plus 4r minus 12, and then go times what? R minus 1 over r plus 3. Now, are we completely factored yet? No. Don't we have to factor the first fraction? The cool thing is, do I have to factor the second one? Yeah, the 11th one is kind of already taken care of for us. Awesome. So, r squared plus r minus 6. GCF? So, it's a trinomial, so we're doing trial and error. Factors of r squared. Okay, what are the factors of 6 we're going to do first? Be logical. Where would you put the 3? Where would you put the 2?
3 in the first, 2 with the subtraction.
Yep. I don't know why I didn't write my other r now. Yeah, put the 3 in the first one because I want it to be positive, right? So plus 3r minus 2r, does that give me the positive 1r? Yeah, so notice I kind of checked away while I was doing it, right? When the numbers are small like that, it's easier to do. All right, denominator. R squared plus 4r minus 12. Again, is there a GCF? No. So we have our plus or minus. Let's finish this one up before you guys go. You've got time. What do we do next? R and what? What two numbers? Do 4 and 3 work? Nope. So it's going to be which one? I heard it. Yep. We're going to go 6 and 2. Okay, guys. Now can we simplify? Look at that beautifulness. R minus 1 all over R plus 6. Homework. I do believe it's textbook work. Guys, this is one of those, does it pay to show more work instead of less work? Yeah. All right, good job. What's the rule for the weekend? Stay safe and what?
Out of trouble.
Out of trouble.
Be stupid.